All right, the first one says, list the next two terms for a sub 1 equals 5 and a sub 2 equals 7. Make sure you pay attention to this if you didn't get it right, because these are important. So the next two terms, I'm going to list the first two first. And then I have to list the next two. So that means I need to list a sub 3 and I need to list a sub 4. Those would be the next two that aren't listed. I'm going to do the third one the way I kind of do it. I do it in plain English. I convert this statement here to English. I just say what it's telling me to do. So it says a sub n plus 1 equals a sub n minus 1. So if I give you a sub n plus 1, can anyone tell me what a sub n minus 1 is in reference to that? Like, is it before? Is it after? How many before? How many after? Yeah.
It's the 1, 2 before.
It's the 1, 2 before. That's a weird way to put it.
1, 2.
It is 2 before. And we know it's 2 before because this is n plus 1. This is n minus 1. So it's 2 less than this one. I have to take 2 away from this one to get here. So in plain English, this says the term I want equals 2 terms prior and then add 5 to it. So going to our third one. This is our third term. Once again, it said go 2 terms back and then add 5 to it. So 2 terms back would be 1, 2 terms back. That equals 5. So in fact, it would be 5 plus 5 equals 10. If you do not like putting it in plain English, or you have a hard time telling what it means in reference to each other, you can also do this mathematically. And the mathematical way to do this is to look at your 4 and look at this n plus 1. That a sub n plus 1, remember, is always the left-hand side. So that's what's matching up here. All of those match up. So when I look at that a sub 4 and that n plus 1, those two things are occupying the same space. The only mathematically for two things to occupy the same space is if they're the exact same value. So since 4 and n plus 1 are in the same space, we can immediately say that 4 must equal n plus 1. In other words, our n would equal 3. And you can double check that. If I put a 3 in for this n, I'd have 3 plus 1, which gives me back out that 4. Well, now that my n is 3, we just keep plugging 3 in for the n. So we have a sub 3 minus 2. So we had minus 1, sorry. We had a sub n minus 1, so I replaced the n with 3. Plus 5, well, that's a sub 2 plus 5. Once again, you have to go back 2 terms, which would be 7 plus 5, which would equal 12. Are there any questions on those? If you can do this one, you can pretty much do any one. Bless you. Because it really is just that pattern. Now, if you could do this one, I could give you a sub n plus 100 and a sub n plus 99 equals, and you just have to know it's the term before. Yes?
So isn't n like the term we're looking for in a sense? Like.
Yeah, because we're looking for what I can plug in all the way across.
Okay.
Yep.
So, I would say if n's the term we're looking for, is we're looking for like a sub 3. I mean, I know like a sub 2 plus 1 is a sub 3, but why wouldn't you just put a sub 3 in for n? I mean, I know it wouldn't work, but like, why wouldn't you do that outside of just because it won't work?
Because it won't work.
But like, why won't it work? Like, isn't that if it's the number we're looking for? Are you just like changing how you write it? Like writing 3 as 2 plus 1 and writing.
Yes, I'm writing 4 as 3 plus 1. I'm writing 5 as. The whole goal is to figure out what this n value is.
Stupid numbers.
And if I just take this 3 and plug it in for this n on this side, if I plug 3 in, it'd be 3 plus 1 equals 4. I'm already on the wrong term. So the number I plug in for n on this side has to work for the left-hand side. So I need an n value that when I add to 1 gives me 3. So it has to be 2 for this one. My n equals 2 for my third term.
These numbers are vicious.
No, they're okay. Okay, the next one says write the series in summation notation. So the first thing I'm going to see is it alternates between negative and positive. As soon as I see negative and positive, I'm going to think to myself, well, self, it's either going to be negative 1 to the nth power, or I'm going to use negative 1 to the n minus 1 power. There's a lot of options out there. You could do n plus 1, n plus 2, n plus, but it's going to be one of those two. Can someone tell me how I can decide which one to use? Nick.
Plug in the first term for n.
Plug in the first term for n. For n, yes. So my first term would be n equals 1, correct? And it should come out negative. If I plug a 1 in for this n, I have negative 1 to the first. That comes out to negative 1. Yeah, negative 1, right? Negative 1 to the first power is negative 1. So that one, in fact, is the one I'm going to take, because if I plug it in here, 1 minus 1 would be 0. Negative 1 to the 0th power is a positive 1. Yes?
Wait, why would you do negative 1 to the positive first power?
Because what you told me to do. So if I'm looking at my first term, n equals 1 here. When I plug 1 in for n, I have to get out a negative term. If I plug in this 1 here, I would get negative 1 to the first, which equals negative 1, which means my first term would be negative. So this is the proper one to pick. Because if I plug that same 1 in here,
You get negative 1 to the 0th power, which is 1.
which would say my first term would be positive, which I don't want. Does that make more sense?
Yes.
Cool. All right. Then continue on. As soon as I take care of my positive and negative, let's not put anything there. We could think of this as just being 1 plus 1/2, not plus. Let's just leave it as 1, 1/2, 1/3. So I'm just trying to find this pattern. Well, just keep the fractions going. I put that as 1 over there. You could go down the whole route and say, well, my bottom is arithmetic. Oh, yeah, sorry.
Sorry.
You sure?
Yeah, I just realized.
Okay. You could go down the whole route and say, well, it's arithmetic. This would be plus 1 on the denominator, just the denominator. That's plus 1, plus 1, plus 1. So you could say your formula is a sub n equals your d times n, which would be 1 times n, plus your a sub 1 minus your 1, so that'd be 0. But I think the easier way is just to point out the fact that my first term is 1 on the bottom. My second term is 2 on the bottom. My third term is 3 on the bottom. So this explicit formula without the positive negatives must be a sub n equals 1 over whatever my n is. Because if I plug a 1 in, I get 1 over 1, which gets me 1. And when I plug my 1 into my negative thing, it comes out with a negative 1. So putting both those elements together, we do have the correct thing. Write it as a summation. Let's use j equals 1, or I guess. Yeah, I went with I. Upside down. I could see that. All right, let's just say I don't know where it's going to end because it's infinity. And then I'm going to throw that negative 1 to the n. Let's I all over I. All over Jack.
All over the chapel door. That was great.
All right, questions on that? Okay, question from the homework. Yeah, Nick.
Number 3. Is the right answer 16?
I don't know. Is there an answer guide online at all?
Yeah, I didn't write it down. I just wrote a question.
Oh, you just put, okay. Oh, here we go. I had the wrong sheet out. All right, number 3 should be 15.
Is 2 to the 0th power 1?
Yes.
Okay.
Table to the 0th power is 1.
Cable?
Sure, cable to the 0th power is 1 also.
Wait, what did you say?
Anything to the 0th power is 1.
Okay.
Everything.
That answered my question.
Yep. I always just say table to the 0th power is 1, just to You can remember it as cable to the 0th power is 1, too.
0 to the 0th power is 1.
Careful there. All right.
Is that even true?
No.
No.
Okay.
So gross.
Things are weird with 0. Kate.
43.
43. 43. So the big thing about 43 and 45 is you just need to plug in the numbers and then worry about simplifying after. Let me do. I'm just going to start it, and then I'll take a picture of what I got. So we have, our limits are 0 and 4, so we're on number 43. Our limits are 0 and 4, so we're going to start at 0. So my first term is going to be a to the 4 minus 0 times b to the 0. Then we're going to bump up to 1, so we will have a to the 4 minus 1, b to the 1. Continuing on, I'd have a to the 4 minus 2, because our value is now 2. B squared. And if you do that all the way through, it's going to look like this. Well, 4 minus 0 gives me 4 here, and we'll have b to the 0th, which will cancel out just being a to the 4th. A to the 4 minus 1 would be that a to the 3rd. B to the 1, because I plugged 1 in for j. And moving our way down will result in that. Okay, so really it's just plug it in and see if you can simplify. Other questions? Yeah.
Is 0 to the 0th power 0?
No.
What is it? But how? I mean, if it's... No, he said it's not 1, though. What is it?
It's infinity.
Figure it out. That's a good thing to look up.
Ask Siri at home.
I don't think it's one
universe.
No.
It kind of depends on how you see exponents and how your answer is going to be. There's 2 ways to see it. But we're not going to get into that. I'm going to go into questions from the homework.
25.
25. 25, we have... I'll do the first couple. So we have a plus a to the r plus a to the r squared plus a to the r cubed. And it keeps going until you get to a to the 10th. Or not a to the 10th, a times r to the 10th. So what I'm looking at is every one of these has r in it. Because I'm going to put r in this one. I'm just going to say that's the 0th power, just to help me. So now when I'm writing my summation formula, I'm going to say, well, I know I need an a, I know I need an r, and my values go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to put a letter above that r because that's what I know is changing. And I know the very first letter is 0, so I can either put I equals 0 all the way to 10, or you may have done this. Well, if I'm writing it, I might start I at 1. My first term needs to be 0, so it'll actually be I minus 1 until I get to 11. Because if I plug in those values, 1 minus 1 is 0. That gives me my 0 here. My end one is 11 minus 1, which gives me my 10 here. Either one of these, perfectly acceptable answers.
Okay, yeah, because I had I equals 1, and then I was wondering why it had to be 11 on top, and then I minus 1 as the...
Yep, it has to be.
All right.
It has to be to get your first term. I always check your first term. So if I just had it to the I, that'd be a little trial and error. If I plug a 1 in, I'd have r to the first, but my first term is supposed to be r to the 0. So the easiest way is just to take 1 off it to make it that 0 to start off with. And then you just check some more to make sure it fits all of them. Other questions? Other questions going once? Now's the time to ask. All right. First thing we're going to talk about is a guy by the name of Gauss, which you've already seen his elimination method. Him and Jordan got together and came up with that. Gauss was a very, 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 very smart man. He was a wonderful mathematician. He really is the backbone behind the way we do calculus even today. Well, Gauss was even really smart when he was a kid. He was actually smarter than all of his teachers, especially in a math class. And that would be very trying for teachers in an elementary school when there's a little kid that's correcting you all the time and telling you how to do things better. Well, one day, Gauss really got on his teacher's nerve, and she was just like, I just want to get rid of you for a while. I'm going to stick you in the corner, and what I want you to do is I want you to add up all the digits from 1 to 100. So that's 1 plus 2 plus 3 plus 4 plus 5 plus 6. Thinking this little kid doesn't have a calculator on him. He's going to have to do all this math. It's going to take him forever to do it. Well, he goes to the corner, and almost immediately he comes back out, and he's like, it's 5,050. And the teacher actually had to do the addition because she didn't know offhand as it was.
A woman teacher?
Or a male teacher.
I'm assuming it was
What was that?
I'm assuming it was a male.
Probably back in that time, it was probably a woman.
They didn't even have a calculator.
Well,
Yeah.
they didn't. They didn't have a calculator. So they had to do everything by hand. So she had to calculate it as well. And sure enough, it came out to 50-50. And
Did he actually get an antenna? Or did you just
it's a story. It's a story. Whether it's 100% true, no one knows. But it's a good story. So anyway, he did, what is true 100% is he came up with this when he was a kid. That is true. What he did is he did not add them all up in his head. What he realized is, well, there's a whole bunch of patterns happening in here. And by patterns, I'm talking about the pairs. He just said, well, if I add 1 to my last term, that's going to be 101. If I add my second term, which is 2, to my second to last term, which is 99, that's also 101. If I add 3 to 98, that's 101. 4 to 97 equals 101. And if you keep going down, you end up getting to 50 plus 51 equals 101. So every one of these pairs adds up to 101. All he had to know is how many pairs there are. Well, a pair implies that each element has to match with something else. So if you count your total elements and divide by 2 for all the pairs you have 50 pairs. So all Gauss had to do was do 50 times 101 to come up with his 5,050. So it took him no time at all to do that. But what Gauss didn't realize at the time was he actually came up with a way to come up with the sums for any arithmetic sequence, because this is, in fact, an arithmetic sequence. It's plus 1, plus 1, plus 1, plus 1. And it just so happens it's not a special arithmetic sequence. And by that I mean his method will work for any arithmetic sequence. It'll work for any arithmetic sequence. So, arithmetic partial sums, adding up. If it's arithmetic, we can use this method. So our first method, and the only one I am going to use, is we have S sub n, and maybe I should just put where n equals our number of terms, is going to equal, well, remember when he had the 100? He just did the 100 divided by 2 to get him his 50 pairs. We're going to do the same thing. We're going to say n divided by 2. That will get how many pairs I have. Then, based upon this 1 through 100 thing, you just have to take the first one plus the last one, and that will get you what your pairs need to add up to. So we're going to take our first term plus our last term, and that's our entire equation. So to this day, I just remember that Gauss story, and that tells me how to do this, because I'm like, okay, he came up with his pairs. He had his first plus, oh yeah, it's in half that for pairs.
I think you were Gauss.
I was back in the day. All right.
You're a vampire.
The sun. All right. The second one. We're not going to use the second one. In fact, I'm going to do the second one, and then I'm going to quickly check my notes to make sure I wrote it correctly, because that's how often. Why not?
I love how your voice went like up and like dove down.
It's not the hardest thing to memorize, but the first one is so much easier.
Oh, this is giving me last year flashbacks.
Why?
Algebra 2 honors was not fun.
Oh, you did these, both of them?
What? Yeah.
Oh, okay.
But probably without the story.
All right, but you don't need to use that second one. So people argue that you need the second one because there's chances where you're not going to know the last term.
Is that true?
It is not true. It is not true because, so let's say I'm going to use the second one.
It would be infinite, and there's no last term.
Oh, for an infinite one? Yeah, there are some that you can calculate. We'll talk about that later. But this term doesn't help you that much because, yeah, you don't have to know your last term, but you do have to know your common difference. You have to know your first term, and you have to know your number of terms. You can find your last term very easily by knowing those few things. So for this to save you time does not really make any sense. Just do this one, unless you're very you like having two equations in your pocket, then know both of them. I just always remember that first one. That's the one we're going to use in class. All right, let's put this to the test. So it says find the sum of 40 plus 37 ... all the way to 22. Well, the first thing we're going to check to make sure it's arithmetic. These are all going to be arithmetic. Just for the sake of it, but they have to be arithmetic right now for us to use that sum. So it is arithmetic. So in fact, both of these are going to be arithmetic. That way I don't forget to check the second one, because the next one is just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're just adding 1. All right, let's plug in the information we know. I need to know my first term, which equals 40. I need to know my last term, which equals 22, and then I need to know how many terms I have. I have 1, 2, 3, 4, 5, 6, 7 terms, so n equals 7. That is all the information you need, because now we're just going to do the sum of all 7 terms is going to equal 7 over 2 times my first term plus my last term, and that's going to result in 217.
Wait, how did you get n?
I just counted. I went 1, 2, 3, 4, 5, 6, 7. I got 7 terms. My n equals 7. For our next one, we're doing the integers from 1 to 35. So that tells me my first term is going to equal 1. My last term is going to equal 35. And my n is going to equal, well, there's 35 of them. And it's just 1, 2, 3, 4, 5, 6, until you get to 35. If you had 35 fingers, you could put them all up.
If you do like that, there's like that awesome method of counting where you like, it's like 1, 2, 3, 4, 5, 5, 6, 7.
Oh, that almost got inappropriate.
Sorry, I tried to do 4 quickly.
Gotcha.
8, 9.
Oh, yep.
I can't hold up my other finger.
Yep, no, that's a cool way.
I
Yeah.
love that.
You just love flipping people off, I think. No. All right. Continuing on, the sum of all 35 of these terms is going to equal 35 divided by 2 times my first term, which is 1, plus my last term, which is 35. And this one you should equal 630 if you actually do the
Oh, that's so nice
calculate.
to know where that ends with a 0. Those are the best kinds. Those are the ones that end with 5.
Or you started, just make sure you did it correct. Our goal is to find our first term, so I need the sum. Remember, the sigma says I need the sum of all of them. So my sum, and it's arithmetic because it's 3i minus 5. That is an arithmetic formula. So we are just going to go, well, I need to find my first term. My first term is going to be 3 times 1 minus 5, which is going to equal negative 2. That's my first term. My last term is actually that 15, because that's my upper limit. So it's 3 times 15 minus 5 equals 3 times 15 is 45. Minus 5 is 40. Whether you're on this problem or not, can everyone just stop and look at me real quick? There are 15 terms in here. That is not why I'm having you stop and look at me. I did not get that 15 from up here. Well, partially I did. You have to know what's the distance between 1 and 15. So you don't automatically assume there's 15 term because it ends at 15.
If it starts at like 3, then it's 12.
It'd be 12. Yep.
Wow.
Yep. So be very careful when you come up with these terms that you check to make sure you're start and stop before you just pick 15 as your n. 15 happens to be our n there because it does start at 1. So now I know my first term, I know my last term, so the sum of all 15 terms is going to equal 15 divided by 2 times my first term plus my last term. And that's going to equal some number, surprisingly not super big, 285.
Another good number.
I don't like 5s. That's evil. 5s and 7s are evil. They just are. Odds as they are evil.
But it's fire. 7.
So now are we going to have to write the sigma out?
No. Oh, for the next one?
Yeah.
No, I'm just asking you to find the sum.
What do we have to know?
Be careful of what I'm asking you. If I ask you to write it out in sigma notation, then you'd have to. This one just says find the sum. To find the sum, I just need to know my first term. I know my last term. But I do not know my n value. There are multiple ways to get your n value. What I'm going to do, so I guess we're prepping writing is, because I would want an explicit formula. I like to write my explicit formula because if I write my explicit formula down, I will give you more points for it because you're doing the right thing. If you know another method and you're just doing your calculator and you turn out with the wrong n and you have no work down, I have no idea where you got your n from and you don't get any points. So I'm going to come up with an explicit formula to find that n value. So to find an explicit formula, we have to have a common difference, and our common difference is 5. Remember, to write an explicit formula for an arithmetic sequence, all you need is your first term and your common difference.
Is that 11?
What was that?
Is that 11?
I don't know. We'll see. It's not. It's close. There you go. So my explicit formula is going to be a sub n equals my common difference times n plus my a sub 1, my first term, minus my difference, so that's 31. So once again, this is my common difference. This is my first term minus my common difference. I highly suggest if you're struggling remembering that, write it down every single time just like that, because the more times you write it down, the more it'll get stuck in your head, and the more when you get to the test, it's going to be super easy to write the explicit form of it. Continuing on, I now know that this is my formula. So I'm going to plug that 91. Ooh, that just crossed it out. Get my 91 and plug it in for my a sub n. So we're going to have 91 equals 5n plus 31. 91 minus 31 is 60. 60 divided by 5 is going to give me n equals 12, doing a little bit of work in my head. If n equals 12 down here, n must equal 12 here also. So our n equals 12. So the sum of all 12 terms is going to equal 12 divided by 2 times my first term, which is 36, plus my last term, which is 91, which is going to result in a super grand total of 760 dose.
Wowza.
Or what is it in German? Feins? Eins?
Zwei.
Phi? Eins, Phi? Whatever. Zwei.
I think.
I'm just making it. All right. I think the hardest form of these is when I... Oh, no, I can't. I'm hitting it. It's not doing it.
How did I not see that?
There is a super sneaky word problem in there.
Is it a sneaky snack?
It's a super sneaky, but it's not super sneaky. We're probably going to make it harder than we need to just because we're going to use we're going to use the words to create an arithmetic sequence because it's good to practice the arithmetic sequence instead of just adding things in my calculator until I get to a perfect number. All right. So reading this, it says, find the total salary for an employee who is paid $20,000 his first year and receives $1,200 raise for each year for the next 39 years.
Whoa.
I'm going to stop right there.
Whoa.
It almost looks like our n is going to be 39, but our n is actually going to be 40 because that first year they got paid $20,000. And then 39 years after that, they each get a raise. So that's why I even threw this in there, that there's 40 annual salaries. So we should already know our n equals 40. Let's start out. So they get paid $20,000 to start off with, and then each year they get a $1,200 raise. That is arithmetic because my first term
20,000.
is 20,000.
Wow.
What's going to be my common difference? They all will give you everything. Yeah.
12,000 or 1,200.
1,200 is going to be my common difference because I'm adding it over and over and over. Once I have my first term, and I know it's arithmetic, and I have a common difference, I can write a formula. My explicit formula is going to be a sub n equals the d value, the common difference, or 1,200, times n, plus my first term, which is 20,000, minus my common difference. So that's going to be 20,000 minus 1,200, which is going to be around 18,800. In fact, it'll be exactly that. So once again, if you're struggling with this, this is what I do every single time. I would write my d value equals that 1,200, and my a sub 1 minus d equals that 18,800. It can't hurt to write it over and over and over until it just gets burrowed into your brain. That's my formula. And before I do anything else, because we're doing arithmetic, that's why I came up with a formula. Well, I'm going to use that formula to figure out what my last salary was, or what, who was this? Did we have a name? Nameless employee. I want to know what nameless employee's last salary was. To find a sum, I need his first salary, and I need its last salary. So to get his last salary, I just have to say, well, my n equals 40 for my last one. So we have a sub 40 equals 1,200 times 40 plus that 18,800. Well, that means his very last, I'll put this as my last term. His very last salary is going to be 66,800. So he was just rolling in the dough.
Except that like the government probably took like tax 60% of that.
At least. Okay. So we need the sum. We now need the sum. Well, remember, to get the sum, I just need my first term, which happened to equal 20,000. I need my last term, which is a sub 40, which equaled that 66,800. And I need to know how many terms I have. Well, I have 40 years of experience working at it. Now I get my sum the same way we did every single thing else. We just say the sum of all 40 terms is going to equal my first term, is 40. I forgot to do the 40 divided by 2. That would have been a big mistake. Then we do our first term, which is at 20,000, plus our last salary, which is 66,800. And we are going to result in $1,736,000. So if nameless employee didn't spend money on anything, they are now a millionaire.
But nameless employee needs to
After
eat
39
Well.
years.
That sounds like weakness coming out of you. I need to eat. I need shelter. I need common human necessities. That's weakness.
Pretty selfish.
Yeah, it's pretty selfish, right?
Did you hear the opera?
All right, but this is not the complete answer. It asks two questions.
Shh. Sorry. That was sort of.
It said basically it wants to find the mean of the 40 annual salaries. So I want the mean, the average. How do I find the average or the mean? Yeah.
Find the total and divide it by 40.
Find the total and divide it by 40, however many your n is. I'm going to show you a shortcut. If you type in 1,736,000 divided by 40, you are 100% correct. You'd have the correct answer. But there's a shorter way to do it with arithmetic sequences. And that is this. I use X bar to stand for my mean. Everyone does, but it just makes your life easier.
Well, everyone jumps off a cliff. Do we do that too?
Depends how high the cliff is.
It depends how high.
All right. To find my mean, I would have to get my total sum and divide by how many terms we have. Well, we have the total sum. So it would be 1,736,000 divided by 40. That would get our correct answer. But I'm going to keep going down this rabbit hole where I don't put any numbers in. I'm going to replace our sum with the formula we have for our sum, which is n divided by 2 times our first term plus our last term all over n. Keep, change, flip this guy. I would keep the top, change the sign to multiplication, and change this to 1 over n. Another way you can look at it is if I multiply the top and bottom by 1 over n, I would cancel this out to 1. However you want to look at it, these n's would cancel each other out. In an arithmetic sequence, these n's would cancel each other out, and our average would actually just be our first term plus our last term divided by 2. That would be our average. So in this case, our average would equal our first term was 20,000 plus 66,800. Divide that bad boy by 2. And you're going to come up with, he made
76,800.
exactly 43,400. Could you imagine if his average was 76,000? He never even made 76,000 in 1 year. It's going to be 43,400. And for those that have a calculator, type this in and divide by 40 and show yourself that that comes out to the exact same answer. Is this always going to be useful? No. Because if I told you to calculate his total salary, dividing that by 40 because you already have it is probably easier. But imagine if the question is just, I know my first term, I know my last term, find the average. You wouldn't have to go through all the work of coming up with all the middle stuff. You can go right to the answer. So this can be a shortcut, or it can be a long cut, depending on the problem. Yes?
It looks like you're calling the X mean.
Yeah.
Mean? You're driving picture. Mean.
Yeah.
It's being
It's being mean.
wearing a hat.
All right, any questions?